Hi to everyone. This is Sindhuja, Department of Mathematics. Let us see the topic of orthogonal transformation of a real symmetric matrix in that quadratic form. So here in this topic we are going to discuss how the quadratic equations were constructed, and from that we are finding a matrix. Our matrix is given and how we are forming a quadratic form. So before going to the topic, let us have a discussion about what is quadratic equation. So in earlier we know that the quadratic equation consists of a single variable x having a degree of 2. For that we use the formula of x is equal to minus b plus or minus square root of b square minus 4ac whole divided by 2a. So here other than the single variable we can go for multiple variables having a degree of 2, and the whole polynomial equations consisting of an same degree. So this equation can be simply named as an homogeneous polynomial equation of second order degree. So example 2x square plus 3y square plus 4z square plus 6xy plus 8yz plus 10zx. So here in this equation x, y, z, three variables having a degree of 2, and the last three terms x, y having a value of degree of 1. So both together we get a degree 2. So likewise in the next two terms you are having a degree 2. So this equation can be simply named as an homogeneous equation having a degree of 2. So let us see how the matrix is converted into a quadratic form. So if you are given with a 3 by 3 matrix such as 2, 1, minus 3, 1, minus 2, 3, minus 3, 3, 4. So when you are converting this 3 by 3 matrix into an quadratic form, we have to consider the main diagonal elements that is 2, minus 2 and 4 as it is, which is in the position of x1 square, x2 square and x3 square. So that we are getting an equation 2x1 square minus 2x2 square plus 4x3 square. Whereas the other elements, so 1. So here in the first row second element is 1. So it is in the position of 1, 2. Whereas similarly in the second row, first element that is A21, it is also 1. So we can write this together as an 2 times of x1, x2. Similarly, the position of x1, x3 is minus 3 and x3, x1 is minus 3. So togetherly we can write it as minus 6 x1, x3 and so on. That is, here we are getting an equation of the form 2x1 square minus 2x2 square plus 4x3 square plus 2x1 x2 minus 6x1 x3 plus 6x2 x3. So likewise we can convert the quadratic form into a matrix form in vice versa. So if the quadratic equation is given, and to convert a matrix form we have to write the main diagonal elements, that is coefficient of square terms as it is, and the other elements should be started by the two places. So we have to divide by 2 so that we get an matrix form from the quadratic form. So to find the quadratic form transformations, we are going with three major steps, that is original form, quadratic expression within mixed terms, and orthogonal transformation by applying an orthogonal method. Then after applying satisfying an orthogonality condition, we are going for canonical form. For this main three major steps, we are following a 9 step procedure to find the canonical form conversion, such as step 1, finding the matrix form by representing, as we discussed earlier, as the matrix form. In step 2, from the matrix we are converting it, finding the characteristic equation, and from the step 2 we are moving on to step 3 as finding eigenvalues and eigenvectors. From that we are checking whether this eigenvectors satisfies the pairwise orthogonality condition, that is x1 transpose x2, x2 transpose x3, x3 transpose x1 are all satisfies the condition as 0. Then if satisfies If the eigenvector satisfies the pairwise orthogonality condition, we are moving on to the normalized eigenvector. So, which is represented by an x by L of x1. That L of x1 is nothing else but length of the eigenvector. So, after finding a normalized eigenvector, we are constructing a normalized model matrix with the help of normalized eigenvector and check whether this normalized model matrix capital N satisfies the orthogonality condition by the formula of n into n transpose. So when you are applying a matrix multiplication, it should satisfy the unit matrix, that is 1 0 0 0 1 0 and 0 0 1. If it satisfies the condition, then we can move on to the next step as a diagonalization, that is d equal to n transpose a n. Then from that we are going to the last as a canonical form with the formula of y transpose dy. So the canonical form is represented by q. So likewise from the quadratic form by orthogonal transformation we are moving to a canonical form. Thank you.